Welcome everybody to our Friday first session of the semester. The objective of these Friday sessions is just for us to be able to try to talk a little bit about topics that I hope are of interest to our systems engineering community, our students and faculty and staff. And also for us to just try to have an opportunity to ask questions and to build a little bit of culture, of course, around scholarship and what we're doing here at the university. So as means of intro, then, my name is Tom Bradley, and I'm serving as our department head and Woodward professor in the Department of Systems Engineering here at Colorado State University. And our topic for today is choosing a research topic. And I'm gonna, we're gonna talk about that, but we'll talk about it pretty broadly. This is a very common question. I think one of the most challenging, most common questions that students sort of come up against. And that's normal. That's sort of part of the process, is that it's difficult to, to come up with a research topic. It's difficult to choose what it is you'd like to study. But what I hope is that I'll be able to share a little bit with you some of the, sort of ideas that I use and some of the resources that I use to be able to think hard about, what that activity might really look like. So let's get ramped up. First of all, here's our big agenda. I'll talk for a little bit about systems engineering research and, what we're really talking about when we think about systems engineering research. We'll talk about some of the, we'll talk about, the general topic here is research topics, but I want to get into a little bit more detail. So we'll sort of talk about research topics. We'll talk about how to compose research problems, and then how to compose research tasks. And ideally, those things sort of fit together to be able to define what your pathway is through the research intensive activities that would be associated with, for example, a doctoral degree at Colorado State University. So let's I'll sort of conclude then with a little bit of discussion about how to communicate research topics and communicate your research ideas, and it'll be responsive to, I think, what we were talking about in the previous sections. So just to kick it off, then, I want to speak about what is research in systems engineering, and those of you who got to attend the talk that I gave last semester that was about what is systems engineering and these kind of things, this might be a little bit repetitious for you all. But my goal in trying to present these definitions and think about it in this way is that it can sort of open up some space, open up some opportunity, some license for us to be able to do research in systems engineering. So oftentimes what I find is that students, when they come into a program, they sort of have some preconceived notions that circumscribe what they think research is, that they think research only happens in science laboratories, or research only happens in doing mathematics or something like that. And so we need to change our minds about that. We need to open up our opportunity to be able to do research in systems engineering by understanding what systems engineering research is. So the first definition I have here, right, is to talk about what is engineering. And engineering, I define it as basically it's organizing these design and construction and operation of any artifice that transforms the physical to meet some need. So a couple of key points there, right? I mean, number one, you sort of see that it includes design, construction, operation. It's got a broad spectrum of technical processes within a product life cycle or a systems life cycle. All of those are amenable to us to be able to make an investment in and to be able to do research in and be able to understand, to be part of our technical knowledge base. So that sort of means that we can look, for example, at requirements engineering, even though it's not really part of design or something like that. It's part of the systems engineering process. And so if we can innovate in requirements engineering or in disposal or in operations and maintenance, those are all equally valid parts of the engineering process in which we can do research. The second kind of bullet point that I have here is that it sort of says, like, look, research is careful, well-defined, objective, systematic method to search for new knowledge. So what does that again, that's a pretty broad definition. It has a couple of key words in there. It means we need to be systematic. We need to be objective. We need to be, it's defined, predefined. But research, the main objective of it is really to be able to develop new knowledge. So almost anywhere, again, within that systems engineering life cycle, where we can develop a new understanding or take new data or tell people how to operate better, or all these kind of things are absolutely admissible modes of new knowledge within the systems engineering context, right, within our field. So on the right-hand side of this graph, you sort of see, this is the NASA systems life cycle, just as an example. One could go to any other of the reference systems life cycles. But even when we talk about broad systems life cycle, we sort of think of things like the systems engineering V. And the systems engineering V is nice, again, because it kind of gives us a model to think about the design phase and life cycle of product development. But not even the systems V is really broad enough, is as broad as this definition, again, right, as this definition of engineering. So it sort of says that, we have a license to innovate and to develop a new understanding and to communicate that in all of these aspects of the systems engineering lifecycle. So I say that again because don't think about research in engineering as only being lab work or only being oriented towards design or has to be identified with the systems engineering V or anything else like that. Obviously, as systems engineers, we take ownership over the entirety of the life cycle of products and systems. And so we need to be able to innovate and to be able to improve the way that we're engineering those systems, no matter where that problem crops up in this life cycle. All right. So now, with that as context, we sort of get to talk about, what I described earlier, which is that I'm going to try to bring to this discussion, again, the title is, how do we think about systems engineering research topics? And I would sort of assert that just having a topic is, that's maybe the easy part. The hard part is to figure out what to do and to figure out what the problems are and to figure out how to be able to solve those problems and get to where we can actually generate new knowledge. So let's not just tackle the easy part. Let's in fact try to tackle the entirety of this problem of coming up with research ideas and executing them and stuff. So let me, I sort of just am going to try to visualize this a little bit here where we sort of say, okay, our objective then is new knowledge, an addition to the systems engineering technical body of knowledge. And when we talk about research topics, oftentimes what we'll talk about is things that might be like, big topics within systems engineering. You could think about things like requirements engineering might be a big topic within systems engineering. Model-based systems engineering might be a topic within systems engineering. Digital twin might be a topic within systems engineering. And so all of those, this body of knowledge is made up of all of those hundreds and hundreds and hundreds of topics that are embedded within the body of knowledge of systems engineering, right? Now, so the idea of defining a research topic is really that, what we're trying to do is sort of say we have a couple of topics of interest within the body of knowledge of systems engineering. And if we can define problems, research problems that sort of, are within our topics of interest, but are outside of the systems engineering body of knowledge, then our objective, and think about this just as a visualization, right, is to sort of compose now, we're going to define these topics of interest, we're going to define a research problem, and we're going to compose a suite of tasks that our objective is to be able to expand the understanding that we have within systems engineering. And the idea is if we can kind of, think about it in that way and use these terminologies or whatever, then I hope that that'll be informative and a little bit of organization around what might otherwise be a difficult task. So now let's just start out then with talking a little bit about what the philosophy or some, philosophical ideas about what might make a good research topic. Because my hope is that what we've done so far is sort of say, there's a lot of stuff out there. There's a lot of opportunity to do research in systems engineering. And so, how do we start to say, okay, these are good ideas or these are good topics and these are bad topics or something, all right? The first thing I sort of say is that ideally, a systems engineering research topic should be aligned with your long-term interests, your long-term understandings of what you would, like to do with yourself and what types of skill sets you'd like to have. You can imagine, I'll sort of draw attention to this diagram here, which is just a purely conceptual diagram that sort of shows that, this is your timeline of your life, intellectual life, that starts maybe at undergraduate, where you learn a bunch of stuff in a bunch of different topics. Don't get too deep into it. It doesn't take too much effort, et cetera, but you're working hard, you're doing your steps and learning. Then you come to grad school and you really develop this, core blue skill set that I assert, and my experience is that this is something that you're going to carry with you through the rest of your career, almost no matter, especially like a master's degree you can recover from, but a PhD, or a doctoral degree, you're going to be doing this type of work. You're going to be using those skill sets. You're going to be in the field for a sizable remainder of your career. Okay. So the idea, though, is that even in time, of course, you'll have new interests and you'll be able to specialize in different activities at work or whatever. But all of that will really be informed, I assert, by the work that you do in your doctoral research, right? So it's sort of going to be a keystone of what you're going to be working on and the skill set you'll be building on for the rest of your kind of like intellectual life, right? And ideally, of course, right, you sort of are able to make that investment, and then it really it can pay off, that the work that you've done, the ideas you've come up with will pay off over the rest of your career until you reach administration in the university or management in your industry and your inevitable intellectual death. And that's, hopefully I can push that off a couple more years. We'll see. So the first, again, criteria is that it really must be something that you're excited about, that you are, that you want to make an investment in. The second point is not that different, which is that it also has to be aligned with your advisor or your collaborators' interests. So many of our, if a student is sort of at this time here where they're really concentrating on hopefully just a couple of key topics, whatever the key topics of your dissertation are, imagine your advisors are a couple of years into, post their PhD. They have broader interests, perhaps, right? That they've been able to build off of their work that they've done. They've been able to build a research and development career. And so it's not like you have to go back 20 years and look up exactly what the topic of their work was, but you should read their papers and understand what the ideas that they're interested in and have conversations, active conversations with your advisor about what type of things they're, they are interested in engaging with you with. So it's, again, it's sort of the criteria here is that not only does it have to be something that you're excited about, but also in order for you to construct an effective team around your research topics, you'll have to also engage your advisor as well. The other, next bullet point, I've only got a couple more of these, but is, that philosophically, again, that I sort of assert that your PhD and the topics that you're interested in, your doctoral research, should really be built on a foundation of your skill sets and capabilities, that you have to tailor the work that you're going to do and the topics that you're going to be engaging with to the things that you are good at. We are going to sort of go through this, you're going to spend a couple of years working really hard on this topic, and you're going to spend the rest of your career building off of it. It should really be something that you're excited about, that you have some unique capability perhaps to be able to do. It's pretty, it's hard for us, I say, to identify our own strengths and weaknesses, for us to be able to think about what it is that we do uniquely well, or that we can, make investments in, or that we can sort of recognize our own personal, superpowers or whatever, right? But the idea is that it can be things. It doesn't have to just be, your research doesn't just have to build off of your programming skills or off of your technical skills. It can also build off of your interpersonal skills. It can also build off of your history, the things that you know, or the experiences that you've had that are unique, whether in industry or in social life or anything else like that. So I sort of, you should try to know yourself a little bit. Try to look deeply at what you think that you can do and what sort of skill sets you can bring to the topics of your interest, and then map that and investigate that in terms of what the research that you're going to be engaging with. I sort of have this little graphic over here that I think tries to highlight this, which is, again, especially in an engineering context, when we think about it, we have a great deal of people, and we train people very well, of course, for great technical skills. And but what you need to be bringing to the research process and to your topic selection process is also those things that are more rare or are not part of the typical engineering skill set, right? If you're an engineer who can do computer programming and you also have some understanding of psychology or some understanding of economics or something like that, that can be really a strength, right? If the opportunity space in engineering, it's very difficult. A majority of the work, of course, in an engineering field will be in the technical sphere. But if you can combine that with an understanding of people or of human factors or anything else like that, then it brings up opportunity for you to be able, you can compose a target of opportunity that's sort of outside the mainstream of engineering research, and that would be a really great place for you to be able to make an investment, right? So it sort of speaks to every PhD student should measure their project and measure their their plans against whether or not they're really the right person to do it. In the same breath, right? If you don't enjoy and are not very good at computer programming or something like that, then you should not compose a topic that is aligned with that. On the other hand, it's very important to think about the time that you're at university as a learning time, of course. So there's the opportunity to sort of make investments in yourself that you'll be able to pay off long term, right? You should think about what type of skills you would like to develop, what type of skills you think will get you to the next important invention that you want to make, or the next type of understanding that you'd like to come to, and be able to sort of identify those and say, I would really like to get better at machine learning activities or something like that. I should include that in my research, even if it's something that I don't know exactly how to do it yet, but I'll take the courses, I'll do the steps, I'll build it up as an activity that I'm interested in the long term. And then now the last thing I was going to sort of say here is, in this research topic discussion is that just like engineering needs to be responsive to a need or problem, we also need to understand that the topics that we're going to choose should also be responsive to a need or a problem here. And so we should look critically at the world that is around us, at the engineering domains in which you all are operating, either in your industrial positions, or even as you go through the coursework, or as you do your investigations. You're looking for opportunity space that is, that is a place where you might be able to make some contributions. And sometimes that can be, you can identify that by doing sort of critical thinking exercises. It's questioning the assumptions of the professors and the textbooks and the papers that you read. It's looking for diverse perspectives on what a problem is. Sometimes people will assert that, all of the problems in requirements engineering are solved right now. Well, that might be true from the perspective of a requirements engineer, but it might not be true from the perspective of a user or the perspective of a manager or something like that, right? You get the idea, but this is the opportunity when you're at this sort of like big topic selection, topic generation stage, to be able to compose a kind of a big or hairy problem, or say, I really want to work in the field of climate change because I think that's a big deal, or I really want to work in the field of cost optimization because this is something that I'm really passionate about, reducing the costs of doing big projects and doing big things. That's the place, this is the opportunity to be able to compose and be able to think about those research topics. I just highlight here a couple of other bullet points, which is that it's also the place where you can go to the National Academy of Engineering and read their reports. They have ongoing reports all the time about what are we going to do about COVID, and what are we going to do about inequity in education, or what are we going to do about the increasing cost of infrastructure in the developing world, or all this kind of stuff like that. That might be very inspirational for you to be able to develop a topic set that's interesting. Okay, so now, the idea is you might start with this kind of big picture. I'm interested in systems engineering, of course. And I really liked that class that I took on model-based systems engineering. And the work that I do right now in my industry job is over here. And so I'm looking for some problems that are kind of in those domains. That's what we mean when we talk about, defining a research topic. So ideally, there will be some overlap between these ideas that you have, between these topics that are of interest. And that's a place where you can start to compose a sort of synthesis of those topics to be able to come up with a research topic. Typical, research topics that you might think about here, I sort of read them out loud. Right? My research topic is in the field of model-based systems engineering applied to responsive and transient space-based communication and networking. Okay, this is some synthesis of space-based networking and model-based systems engineering, and a charge that comes from the National Academy of Engineering to start thinking about responsive and transient space-based communication. It doesn't really say what I'm going to do in that place. It doesn't say, I don't know exactly quite yet what the problem is, but the topic can be defined, or at least you can be down selected by thinking about those considerations that I've advanced for you so far. Now we get to the sort of next stage, which is, all right, now how do we then translate that from being a research topic into some problems, into research questions that we can use to drive our research activities. So let's assume that you emerge from that research topic idea with something that sort of says, I don't really know what the problem is yet. I don't really know what I'm going to do, but I'm interested in something that is, these intersections of these broad topics. And certainly it's within the topic of systems engineering. Now your goal is to kind of try to ideate some practical research problems that are in or around that feasible space. I should have highlighted that. I mean, these are these targets in the middle of that sort of feasible space there. And if folks have watched on the website, I have a lecture about observe, reflect, articulate, and it's just a mechanism by which we can do sort of ideation and these kind of things to be able to come up with research ideas. So I won't go through that here, but I just bring it up as a means to be able to do this. So the idea is you might take a couple of those research topic sets that you defined, and you sort of say, model-based systems engineering and space-based communication, I need to go and I need to do the sort of background work, and I'm going to go and I'm going to investigate those. I'm going to observe what the field is saying about them. I'm going to look at the textbooks. I'm going to, try to repeat some of the problems that people have solved in the past. And by doing that, you sort of are entering into this observation stage where you kind of take those, you might have a couple of key targets that you sort of say, this is within some of my research topic scope. I'm going to expand on those. I'm going to seek to understand what's going on in that space. Then the next step is you sort of then try to reflect on those. And those are kind of like synthesis and comparison tasks where your ideas can bounce off each other. You can compare what this group did to solve a problem in your topic space to what that group did. But the idea is you now start to sort of compare and contrast and evaluate various topics that, and problems. You start to define problems within your research topic. So I recognize, and I'm going to say out loud a couple times, that this is all uncertain. It feels uncertain when you're doing it because, right, you don't know whether you're going to come up with a really great idea, and then the next day you open a book and somebody wrote a book on it in 1972, and you sort of say, "Oh, darn it! Okay, well, I'll have to go back and think." So it is uncertain. It is risky. You're taking a personal, professional risk in saying out loud to your advisor that I think we should study something here. But that's part of the challenge, part of the the courage that it takes to be able to think hard and work hard and to innovate, right, to do research. So I sort of highlight here again that, okay, from that topic set, your job then is to sort of start to investigate, observe, and synthesize research problems that you can see within those topics. Now, let's dive deeper into what the sort of way to think about these research problems are. Of course, you've just, I just gave you the pitch that you're going to do this observation stuff. Much of that comes from observing the literature. It can be observing the way that best practices happen in industry. It can be from going to conferences and seeing what other folks say, et cetera. But your work should really, your research topics, your research problems should be reactive or constructive to the others' work in the field, right? So you will accept, it's inevitable that you will come up with what you think is a great research problem and just understand that somebody is going to have already been doing work against that problem. Does that mean that there's nothing new to discover there? Does that mean that that the other group at South Dakota State has a lead on us and we should just forget about it or something? No, not at all. In fact, we need to be accepting of and expect that research, discovery, this is all going to be a team sport. And so we have to understand that there will be other people working in this space. So you should look at them and say, look at their work and say, are they solving exactly the right problem, or are critically, are they not seeing the big picture? Is there the opportunity for us to solve this problem in a more optimal way, et cetera? So there's much. The figure here sort of points to. I wrote a paper that was about looking at research that other people had done, and we kind of came up with a concept that was difficult to decarbonize sources of industrial CO2 emissions, et cetera, right? And so you kind of go, is that like a completely novel idea? No, I mean, people have been doing work in that space for a while, but what we're able to do is kind of put a pin in it and synthesize what other folks had been doing and be able to say, oh, there's kind of something here that we should bring up and put a name to. And that can be a form of composing research problem. That can be a research problem, is that people don't have a framework to be able to understand these bigger ideas, right? So don't be scared of the fact that there are people working in your problems. We just need to be responsive to it. The other part is that we should recognize, especially, I gave you the pitch that you're going to be, you may be very interested in manned mission to Mars or something, or you may be very interested in solving global warming. Those are all, we're all interested in all those topics, but we have to recognize those are lifetime research topics to be able to get that, to solve those problems. And so instead, research problems should really be composed as one of a series or of a composite of research problems, right? If our goal is to get at, I really want to reform the way that the Veterans Health Administration operates to make it so that they can handle the next pandemic, that's a great goal. We should compose, that's a really nice problem to solve. We can identify what all the problems are within the Veterans Health Administration for being able to be pandemic ready. But also we need to recognize that there's probably 100 new things that we need to discover, new understanding that we need to build, recommendations that we need to make and defend, problems we need to solve before we can get to that final state. And so just recognize that you will not be able to solve all of those problems in one swoop. Instead, we need to think about those problem sets as being constructive with other researchers that are going on in the world, constructive to each other. So scope your problem so that it's doable in a couple of years of work at the university, and recognize that even if you are able to take a few big chunks out of this problem set, it will also take other people doing research in other domains. It's not just a technical problem, it's also a procedural problem, it's also a human problem. And together we can be able to reform the way that we do mission to Mars, or the way that we do pandemic preparedness or something. But don't think about it as just being as a research problem being the identification of one activity or one thing that we really need to do. Think about it as all the ways that we're going to get to that end space. The next point here is that we need to be it's easy to say, but we need to be aiming for new information, right? And it's oftentimes I find students get really tripped up in that they might have sort of a research problem that they can define. Okay, I want to be able to design this part, but people don't do it very well right now. But how can I show that nobody has ever done it the way that I'm proposing to do it? Or how can I show the negative, right? That is, what is it that the field does not know? And the answer there is that it's sort of philosophically impossible to show that nobody has ever done this or something like that, right? But what you do is you build off of these others' work, right? You compare and you contrast what you've proposed to what others do. You can do things like look at that there's particular parts of the literature and parts of academia, parts of industry that try to codify what the state of the art is. They're called review articles, or even books, textbooks, for example. That's exactly what the point of a textbook is. It's a collection of all the things that we sort of know to be true and that we know to be the way that we're operating right now. You can also look at things like failures. It's very obvious that if a battery inside of an aircraft is catching on fire, that we don't know how to do that very well. And so if you can compose ways to do that better, then it's pretty easy to contrast that to the state of the art. You can look at ideas like common sense. It's often easy to go to, sometimes popular literature or even experts, and they say things like, it's impossible to do a airplane that is powered by batteries or something. Well, maybe we can think hard about that. Maybe there's the opportunity to challenge that. Maybe there's the opportunity to measure what is unmeasured right now. All of these are ways that you can, and again, it's building an evidence base, but it's demonstrating that you understand the state of the field, and that your work is truly novel. And then the last piece I sort of have here is that we need to make sure that the research problem that you're defining is truly a systems engineering research problem, right? So I say this in a couple of my courses, right? But we need to make sure that we're defining our problem to be a systems problem and not a disciplinary problem, not just an electrical engineering problem, but actually a systems problem. How do you make the case that this is a systems problem? You have to think about, what are the ingredients of a system, right? It's that it has components and interactions and interfaces and dynamics, and it varies, its behavior varies as a function of time, and it interacts with an environment, all these kind of things, right? So make the case and help us to understand that in fact these are systems problems, and then that will also help you in down selecting from a set of problems that would be disciplinary problems to systems problems. And if it's not, if you find that a problem that is very exciting to you is not a systems problem, like that's okay. Components of your systems engineering PhD could be disciplinary research tasks and such, but you really want to make sure, of course, that your research is centered within the field of systems engineering. Okay, so now, this kind of gets at, we've started with this big idea of research topics, and you sort of say, okay, what are the topics I want to do? You execute this observation and reflection type stages that you sort of say, okay, now what I've done is composed what I think are a couple of research problems. I think, that it looks like they're novel. It looks like they are actually systems problems. It looks like, we have it meets all these criteria that I kind of laid out there. And then, so then the last stage of composing research activities is to be able to now articulate this sort of step-by-step tasks by which you are going to solve that research problem. And I should use air quotes or something around the word solve, because it's not really about solving it, because we just made that case earlier. It's really about pushing the boundaries of what we know to be able to push that frontier of knowledge outwards and contribute to the solving of that problem, right? We won't be able to solve pandemic preparedness in, our collective efforts. We will have to do that as a society, as a research field, as all those kind of things. So the point is, it doesn't have to solve that problem, but it does have to expand that frontier of knowledge. So we now enter this articulation phase, and the work package that is the result of that articulation phase is research tasks. So underneath each one of these research problems now, we can compose a couple of research tasks that the objective of which is to now sort of systematically define the activities that we're going to use to be able to generate new knowledge. So let's say, what is the characteristics of good research tasks? Get formulaic here again. The first point is, any task, of course, is an activity. It's a verb, right? And so make sure that you're thinking about research and discovery and synthesis, higher modes of learning, higher modes of thinking activity when you use these verbs. So each one of these tasks should be some unit of research activity. It should have concrete outcomes. And I give you a bunch of keywords here. It can include measurement and review and quantification and survey and all these kind of things like that. But research activities, research tasks should not include things like merely demonstration. If you're just demonstrating the state of the art or something like that, that's not really building new knowledge, right? You could demonstrate it and then use that for validation and verification or something like that. Okay, well, that sounds like those are the right words to be able to illustrate that you're actually generating new knowledge. Implementation of best practices, for example, is not we already knew best practices. That's why they're best practices. And so don't implement them and tell us that the best practices worked. That would not be a demonstration of new knowledge. You could, so I sort of give, again, maybe some words that you could use to be able to describe research tasks. Might be, okay, compare and report the characteristics of a set of AI technologies to the need of some standardized system safety process. So you could implement best practices, you could demonstrate this ISO system safety practice, but that's not really the research task. The research task is to compare and report and be able to synthesize what the differences are between these things, right? So you build up these research tasks piece by piece to be able to support this stepwise transition, the stepwise construction of new knowledge. When you think about your research tasks, they should be supportable by the available, you should measure or not, or understand whether or not they're supportable by time and such. Whether you have the right tools, whether you have the right data, whether you have the right people on your team, all this kind of stuff like that. Of course, the power of being at the university is that we do have extraordinary resources for being able to do R&D. And if we don't have it, then certainly our colleagues at universities across the country do. And we can leverage all that to be able to do your work. But there is a risk that if you launch on tasks that are not feasible, that are not scoped to your available time and tools and such, then you can fail. And I'll say most of the places wherein I've seen research fail, it has been due to lack of resources. It's not that it was impossible or something like that, but we just ran out of, we didn't have the right data, or we didn't have the right amount of time or something. So it speaks to that even as we do these research tasks, it sort of sounds under control, but there's always an irreducible risk of failure as we're doing research. There's always the chance that that boundary in what we know was there because other people have failed, and we fail as well. And that's part of the risk. That's part of what is okay in doing research. So then the last step here is that, we sort of say the research task should really be sort of, again, like stepwise contributions to new knowledge, stepwise contributions to solving whatever this research problem is. So I give you an example here, which is that you're aiming for one, research task 3 builds off of 2, builds off of 1. You can see it. We sort of make the models and validate them. Then we do some comparisons to the state of the art, and then we use the results of optimization and optimal design to be able to derive some optimal subsystem relations. That this part has to be double the size of that one because that's the way that we get optimal supersystem operation and those kind of things, right? So it sort of speaks to that what you want to do is you want each task to be contributing and built off of the task before it and contributing to the activity of the task after it. And if you do that, then the benefit is you're sort of making one step in front of the other to be able to advance our state of the knowledge towards solving this problem. If you don't do that, if they're all orthogonal or something like that, then okay, there still can be benefit to that, but it means you're sacrificing a little bit of the amount of understanding that we come out the other side with. An important, the last point here again, it speaks to this recurring discussion about risk, which is that you should expect, it's okay to put in these tasks that you're going to learn as you go, that you don't know what those relationships are. You don't have to hypothesize them beforehand, because 99% chance you're proven wrong. So it's okay to say, once I discover what those relationships are, I'm going to design a test apparatus that will be able to see whether they actually work in the application. Great, that's great. That can be a totally acceptable research task that you use to define your project. So, okay, now what we've kind of, what I hope that we have now sort of talked about is this 3-step or 3 levels of focus on defining a research topic. Now, what I really find again is that all the time students jump to making research tasks. They sort of say, oh, I should be I should be doing work in the first week that I arrive here at the university, or by the first meeting that I have with my advisor, I need to be very sure what my research tasks are and stuff like that. And that's just not realistic. These activities, these discussions, these evaluations are things that you should be engaging with your advisor and engaging with your other grad students or people in your courses or your professors in your other courses. This is again difficult, risky, high probability of failure, high probability of you come into a meeting with great ideas and your professor says, I actually already did all of those ones. So keep thinking, all right, that's fine. That's the way it goes. But the point is, think about it instead of being a lightning bolt that strikes down and tells you exactly what topics you're going to be working on. Instead, this is something that needs to be generated through authentic engagement, hard thinking, evaluation, etc. So now I sort of hope just to, the last couple of slides here are about, by thinking about research in this way, what my hope is that this can help us to communicate research topics and ideas to others as well. When you do your proposal, we were talking about that earlier, when you do your dissertation, when you write that, when you do your defense, you will have many opportunities to be able to give the pitch, to be able to talk about what your research topic is. And there's a mapping between your introduction to your first paper or your introduction to your dissertation can define the research topic. You sort of say, there's a lot of need within systems engineering for a model-based approach to system safety in advanced vehicles that include artificial intelligence. That case is now easy to make if you can put that research topic at the front and center of your introductory paragraphs that are the intro to your dissertation. Your background, I've used the word research problems. I also, in other contexts, urge students to compose research questions. Those are all, again, driven by what those research problems that you've defined are. You're going to sort of say, I want to be able to design this with a better method. I want to be able to get a more robust design. I want to be able to input these requirements earlier in the design process. That's that problem composition is something that will directly feed into your background and research questions sections of your dissertation. And then the research tasks, especially in the proposal, but also as you compose papers, as you write your journal papers that are the product of your research, those research tasks become your methods section. They become your discussion sections, all these things. So what I would sort of say is embrace the idea that you are going to, everything that you write and everything that you are building up and everything you're thinking about and the conversations that you're having with your advisor, capture those, take advantage of them, reuse them as you are composing your work products for your research, and you'll be well served. The other place that this kind of an idea comes up a lot is that you're going to do, you're going to have conversations with your boss, and you're going to have conversations with your colleagues at a conference or something like that. And so it's worth your while to compose a research elevator pitch. And the research elevator pitch, I steal this from a website that's talking about elevator pitches and all these kind of things like that. But their highlights of what you should be talking about in this elevator pitch are exactly aligned with what we've just defined. That you say, oh, my topic is the multidisciplinary optimization and systems design of fuel cell power plants applied to aircraft. The problem is that people have been trying to design this for a little while, but we don't have very good models of the way that that these trade-offs are being realized, et cetera. Okay, so the point is you should, as you define these things, you can refine them. You can start to have them be part of what you can talk about. And this is a good means for you to be able to communicate research topics and the research ideas that you have with your colleagues, with your boss, with your advisor, with your committee, et cetera. So the point here is, my hope is, I'll leave time for questions. I think, the purpose of coming back to grad school, the purpose of being here and of talking about these things that we are talking about is that this is really trying to build, it's a unique opportunity in our lives to be able to build the capabilities for us to be able to spend our career engaging with scholarship and engaging with innovation and being curious and active participants in research and development activities, right? So you should kind of, this model that I've given, or this kind of discussion that we're having, I sort of assert that this is something that you are going to be doing continuously while you're at the university. And it's something you're going to be doing continuously for the rest of your career as you're engaged in R&D activities. So you might as well kind of start doing it. You might as well start thinking about it. You might as well start capturing what your ideas are, making investments in them, discounting some, promoting others, and just recognizing that this is one of the things that is intrinsic to what you're supposed to be doing in graduate school. And so, yeah, there will be a perfect time for it. There will be there will be a time in which you have to sort of like buckle down and start doing the research activities themselves. But at least one of my hope is that by talking about this out loud and by talking about it with a little bit of structure, we can sort of say, yeah, like this is something that we do. This is a process that we're going to be engaged with for, continuously while we're here and ongoing too. recognizing again that this is difficult. It is uncertain. You're going to go with your, it's sort of, you're going to wear your heart on your sleeve a little bit every time that you get up in front of a conference group and say, this is the research that I've done, and I think these are good ideas, and these are the ways that we think we should be solving these problems. There's a risk embedded in that. There's the risk that you could be, you could be wrong, or that people won't like your ideas or something like that. And we just need to get, that's part of the risk of being an innovator. That's part of the risk of being a collaborator. And so, yeah, we just, my hope is that by talking about this out loud, we can demystify what is, I think, a tricky and risky process. And the last charge is here really for you to be able to engage with your advisor on these things. Again, I love having the topic. I love having the conversation about what students' research topics are. I love to hear your creative ideas. I love to be able to share my understanding of systems engineering, with the big goal, of course, for me, of pushing off that hard deadline of intellectual death or whatever, administration lobotomy, off into the future as far as is possible. So, okay. With that, that concludes our discussion a little bit, or my talk about what the ingredients of research topic is. And I'm open to questions and further discussion as anybody might like. So thank you for your attention. Delighted to have a great crowd. Thank you.
Hey, Tom, it's Bo. Are you there?
Yes, go ahead, Bo.
Oh, hey, just a question I get from my students a bit is, where does the literature review sit within all of this? Is as you start to get, some general topics, is that the place, or should you start earlier or later? I'm just curious as to where you think that sits, or maybe there's multiple literature reviews. I know I'd just like your thoughts on how that contributes and maybe where that would fit or fits within the process.
The answer there is going to be like continuous, right? I mean, but with different purposes. What I sort of asserted again is, at the beginning, what you're trying to do is, as I talked about what the topics might be, the topics are things that are, that you will have to understand systems engineering to be able to understand what the systems engineering body of knowledge is and stuff. But it's, in those cases, the criteria for that are really more, where do you think you can be successful, and where do you think your advisor can connect with you, and what are you really interested in, these kind of things. Now you have to, again, that's built off of a foundation of know-how and of expertise and stuff. So you have to get there. But then also I described that as you start to populate research problems, as you start to develop them, that we can do that observation or reflection activities. And both of those are really driven by an understanding of what's going on in the field. So that's where I really referred to. Go into the literature and see what other folks are doing and compare what you're doing to what they've done, and look for new techniques that you could apply to old problems. That's really also, again, based off of literature review. So worthwhile to be engaged with that, perhaps continuously. Open to other questions. I'd urge folks just to speak up, just as you heard Bo do. So, yeah.
Tom?
Hey, Dean, go ahead.
So great illustrations on the kind of a research topic. I just really appreciate how you laid this out, but I'm curious to get your understanding on, what advice could you give someone in terms of how to come up with a research topic? I mean, you've sort of defined what it is, but how, what would be your suggestion on how to come up with one that fits that criteria?
Yeah, I think there's, again, my hope, and I think that the way that you can be most successful is look at your internal sort of motivations, right? And look at what you are interested in. I think those are some of the key kind of, measurements that I'm talking about there, is like, look for what you'd like to do. I mean, this is something that you should be sort of, obviously you've got the skill set, you've got the work ethic, you've been doing all the steps. Look at yourself and sort of say, like, what is it that I would like to achieve, and what kind of things can I be really making a deep investment in for a couple of years here that I think will serve me long term. You can also, it's appropriate, of course, to ask practitioners or people around you or bosses or colleagues or advisor for what research topics might be of interest. But even then, you have to measure that again against what you are capable and interested in doing. It's very common that somebody would say, oh man, the biggest, hottest, coolest stuff right now is digital twin. Oh boy, everybody loves digital twin. And if you're bored by digital twin, do not make a 4-year investment in digital twin. That's just, don't even go there, right?
Right.
So maybe that's kind of what I'm trying to say is like, I want everybody to be composing and thinking about their PhD as a personal project, and so I think that's a key ingredient for success. And so if you can think about it that way, maybe that's helpful. Yeah.
One piece of advice I got a long time ago, be curious to get your reaction to it, was to get into the academic peer reviewed journals in the areas of interest to you, and find a current robust literature stream on a certain topic that you think you might be able to add a little tiny bit to. Was that good advice, do you think?
I think that's fair. I mean, I guess that my only challenge would just be there's so many of those that are going on. There's so many frontiers of systems engineering that it would be very easy to say, oh yeah, I mean, again, well, also model-based systems engineering is really hot. And should I do that? Also, INCOSE just put out a new requirements engineering document. Maybe I should do that. Also, et cetera, et cetera. So it's, again, I think it's very easy for students to get sort of like waylaid by so much activity that's going on in the field. And so the only way to overcome that, I think, is you have to down select. You have to decide what it is that you're going to push on.
Thanks.
I'll jump in there. I'm a doctoral student with Dr. Chandra, and I'm in industry. And so there was working with him. We've finally got on a project, but it was, as somebody in industry, I've worked a lot of items, and he had to actually get me more into that research mode, that thought process where you will just have a little bit coming into, as opposed to the cradle to grave project that will be the answer.
Yeah.
And so anybody else that's in industry, sometimes that's hard to overcome, because in work we aren't paid for it. Hey, great, you got the first slide done. It's like, no, we need the answer to the solution, to the problem. And so it was very helpful. I appreciate your briefing on that. It was helpful for hearing that again. And as was said before, I'm getting into the academically peer reviewed journals has been very helpful for me, as a different to the industry journals, which are a different angle. Yeah.
No, I'm grateful for your perspective there. And I think as you recognize, no doubt, I mean, many of our students are treading that line between industry and the university. And so it is, this is part of why we're doing this, right? Is it's like, we have to share cultures about this. We have to share expectations and make sure we're talking the same language. And if we do that, then my hope is that can make you all successful in checking the boxes that we have over here at the university.
Tom, Alan Clayton here. I just wanted to pile on to something you said, because I've heard it now multiple times. It's to play to your strengths. And for example, my strength probably isn't programming, even though I survived Dr. Daly's class. The other thing that students get mistakenly wrapped up in is you kind of have to apply to the program saying, I'm going to go do this, as if you know that you're actually going to do that and be successful at doing that. I've had to switch direction multiple times already. And my last big push, I found, as you said, oh, look, here's a paper published on that. It's been done. And my advisor, and I'll go ahead and drop a line here and say, Simsky really helped me out on this. He says, well, that proved you were on the right track.
Yeah.
Now, take what was done, build on it. Okay, it doesn't mean you've now got nowhere to go. It means you were on the right track.
Yeah.
So my strength is not on where I started, I found out. My strength is now where I'm headed, because I found out I can play to my strength on this. And being wrong is a gift.
Yeah. Yes, I appreciate that sentiment. You know, again, we have a myth of that, you know, smart people don't make mistakes, and we have a myth that when you know, that it becomes that great ideas just fall from the sky and hit us in the head or something. And that's just not the way that the world works. So we have to get dirty. We have to take that risk. We have to say, you know, I thought this was a good idea and it didn't work. You know, I spent 2 months working on it. It didn't work. That's the way it goes. But that's what we're signing up for, with a life of authentically engaging with the frontiers of what we know how to do. So that's the charge, and it's an exciting charge to be able to be responsive to, in my opinion.
Thank you.
Will your slides be available, Dr. Bradley?
Yes, yeah, I'll have Catherine will post them up and stuff.
Thanks.
Other comments or other refutations or reactions or anything?
Hi, this is Olivia. I'm going to just plug your 780 class because a lot of the questions that I had, you're getting into the level of detail that I wanted. So if you want to learn how to be a really good PhD student, please sign up for that class.
That's very generous. Thank you, Olivia. Yes, I do recognize a bunch of the names here and stuff like that, but that new course is really designed to try to help folks through the PhD. So if these topics are interesting or familiar and frustrating to you, then 780 might be just what you need. So, well, I'll maybe just again thank everybody for participation and for attention. Delighted to get to talk to you a little bit about this stuff. And yeah, let me know if you have any questions or comments, and look forward to more conversations as we keep doing these Friday talks. All right. Cheers.
Thanks again.
Thank you.